Hey guys, welcome to another lesson. Just continuing from the previous lesson where we did friction. Now, previously we only covered horizontal surfaces with friction, and today we will cover friction on diagonal surfaces or slopes. Right, so we'll get into it straight away. Got a question here. As always, draw a diagram, pause, resume, and then we'll have a go. Right. So first, always see what the surface is. Now, the question is telling you it's a rough plane inclined at 30 degrees to the horizontal. Rough means you will have friction. Okay. Um, a particle of mass 5 kg is placed on the slope. Um, and then look at all the forces that we have. Now, the particle will obviously slide down, right? Because it's natural for anything to be placed on a slope to slide down. So the particle will slide down. That means it will accelerate this way. Okay. Now, friction happens opposite the motion. So this will be your friction. Right. The other force that we have is your normal reaction, which will be this way, and your weight. Now, weight is mg. So Cambridge, you take gravity as 10. Mass is 5. So 5 times 10 is 50. Now, as we've done before, whenever we have a slope, we need both the components of the weight in the direction of the slope and perpendicular to the slope. Okay. So let's use a different color here. Right. So the one opposite is sine. Right. So this will be 50 sine 30, and the one adjacent is cos. That will be 50 cos 30. And so we've got all those forces, and now we can start our um, F equals ma. Right. First, what we'll do is we will focus on the perpendicular direction. Okay. Now, the object is moving this way. So here you will have acceleration. It's not moving this way. Yep. So we'll do this direction first. F equals ma. A is going to be 0 because it's not moving in that direction. Um, Now, if acceleration is 0, you can do up minus down or down minus up. It doesn't matter. So I will do up minus down equals ma, which means in this you'll have up minus down equals m is 5, acceleration is 0. Okay. Now, going up is your n, yep, which we had here. Going down is your 50 cos 30. Okay, equals to 5 times 0 is 0. So n equals 50 cos 30, which is 25 root 3. Right, so we've got our value of n. Okay, now, before I move to the other direction, we know the formula for friction, which is mu times n. Okay, now let's substitute that. So 0.3 from the question times the value we just found, which was 25 root 3. Okay, that gives you 12.99. Right, so now we've got friction, and now we can focus on F equals ma in the direction, the other direction, which was the direction of motion. Okay, so now we'll do F equals ma in this direction here. Right now, the particle is going down, so I need to do down minus up equals ma. Okay, make sure you get this bit right, the order. Whichever direction the particle is traveling in, that direction comes first. Because it's going down, we will have down first. Okay. Now, going down, we have one force over here, which is 50 sine 30. Okay. And that's it. And going up, we have the friction. MA, so 5A. Okay. Now, 50 sine 30 will give you 25. Friction, we calculated, was 12.99 equals 5A. Now, if we solve this for A, that should give you 2.4. Right, so we've got the acceleration. This is a basic question. Not many forces here. It's just a particle placed um, on the slope. Okay, so moving on. Okay, so next one. Again, so pause the video, draw a diagram with all the forces, and try to resolve it, and then resume, and you can go through it with me. Okay, so a slope which is inclined at 30 degrees. The particle is 7 kg. And the particle is being pushed up. Okay, so what that means is the direction of motion is up. Okay, now it's being pushed up by um, a force of 20 N. Now, what's important is how this force is acting, which direction. Okay, so this force of 20 newtons is acting parallel to the plane and it's pushing up. Okay, now parallel to the plane means your plane is the slope, right? Which means it's like this. This is your plane. So parallel to the plane means in the same direction. So your 20 newtons is acting this way. It's pushing up. Okay, now because the particle is being pushed up, friction will act opposite, which is in this way. And the other force we have is the weight. Okay, so mg 7 times 10 is 70. Okay, and then you have your two weight components that you always need on the slope. So down. Right, so opposite you will have 70 sine 30 and adjacent will be 70 cos 30. Okay. And you also have your normal reaction going upwards. Right. So now that we've got that, all the forces, we start off with F equals ma. Just gonna rub this off. Right. So first we will do F equals ma in the direction where a is 0, okay, where the particle is not moving. So we are doing F equals ma in this direction. Right. Again, because a is 0, it doesn't matter if the particle is moving or not. So let's do up minus down equals ma. Now, going up in this direction is your n, and going down is your 70 cos 30 equals to 7 times 0. So n equals 35 root 3. Right, once you've got n, you can work out your friction. Right, this is your friction. I'm using 6SF because this isn't the final answer and I need to use it again in the next calculation. So ideally you want the full digits on the calculator, but this should be enough just to make sure there's no rounding errors in the final answer. Right? So we've got friction, and now we will move on to F equals ma in the direction of the motion. Okay, so let's do that over here. Right, now remember the particle is being pushed up, so our motion is upwards, which means we have to do up minus down. Okay, so going up minus going down. Right, now going up, we have the 20. Okay, so let's do that here. And going down, we have two forces. One is your friction, which is here, and the other is your 70 sine 30. Okay, so we combine these together. Equals to MA, so 7A. Right, now we solve this. So 20 minus, now we already have the value of friction, 18.1865. We add that to 70 sine 30. Okay, that gives you 53 point. Okay, and 20 minus that gives you negative 33.1865. You divide that by 7. A equals minus 4.74. Okay, because it's negative, that means we have deceleration. So the particle is slowing down um, as it's going up. Right, so moving on to the next one. Okay, always start with the diagram. Try this yourself, and then you can pause and resume. Now it's being pushed up by a horizontal force of 20 N. Okay. Now this force is horizontal, which means it's acting like this horizontally. Now, this is a tricky situation because we don't want um, horizontal or vertical forces. We want all our forces to be either parallel to the slope or perpendicular. So we don't want the horizontal one, 20. So we need to find the two components of 20. Right. So with the horizontal forces, okay, so we just draw a quick triangle, um, which will allow us to get forces in the same direction as the plane and perpendicular, right? So yep, so we're starting here, going down and then right, and the ending point is the same. So we've got the directions, the two arrows, correct. Yeah. Now this angle will be 30 because it's a Z angle, as we did before, parallel. Okay. Um, the opposite, if you go opposite the angle, this is sine, so that will be 20 sine 30. Okay. and the adjacent will be 20 cos 30. So we've got those two forces. The other forces we have are the normal reaction. Okay. The particle is being pushed up. That means friction will be acting down the opposite direction. And the weight, mg, okay, weight is 70. Now, again, this is vertical. We want the two components of weight so that they are in the direction of the slope or perpendicular. So opposite is sine, 70 sine 30, and adjacent is cos. Right, once we've done that, we start working on calculations. First, we will try to find n. So we will do F equals ma in this direction. And now, in this direction, a is 0 because the particle is not moving in this direction. It's moving. The particle is moving like this. So we'll do this afterwards. Now, a is 0, so you can do up minus down or down minus up. Doesn't really matter. Now, which forces are going upwards? So we have the n, which is going up. Okay. And that's it. Now, going down, we have two forces, so we will combine them. This one, 20 sine 30, you can see by the arrow, it's going down. So 20 sine 30. And we also have this weight component, 70 cos 30. This is also going down. Okay, and this is equal to 0 because 7 times 0 will give you 0. Okay, now we calculate this to find n. This should give you 20 sine 30 plus 70 cos 30, 70.62. Okay, so again, I've used 6SF so that we don't make a rounding error in the final answer. Ideally, you can save your answer in the calculator and use that again. If you don't know how to do that, watch my video on saving values in the calculator. Anyway, so we've got n here. Okay, now we had the coefficient of friction 0.3, so we can use that to find our friction. So 0.3 times okay, so we've got friction, and now we can do F equals ma um, in the other direction. So we can calculate the acceleration. So we are doing this direction here. Now the particle is being pushed up So we have to do up minus down. Okay. Right now, let's look at the forces. Now going up, we have 20 cos 30, which was here. Yeah, you can see by the arrow, it's going up. So 20 cos 30 minus going down, we have two forces. We have 70 sine 30 and friction. Um, Now we already have friction from, so we'll use the friction value that we found before, 21.1865, right? So let's try solving this. Right, you get A equals negative 5.55. Again, it's negative, which means it's a deceleration. Um, right, just try one more. Okay, now most of the time, the question will involve friction. This is for rough surfaces, right? So the friction is a type of resistance, like air resistance and other types of resistance, right? Um, there will be times when the question will just say resistance force, right? So in this type of question, you don't need to consider friction separately, okay? You just consider the resistance force, and that includes all the resistances, including friction. So then you don't need to think about friction or the coefficient of friction separate. Okay, but most of the time you will have friction questions.